We'll proceed in vector, summation, and integral calculus. Okay, so mind-blowing vector summation and integral calculus, the arena in which we are proceeding the discussion, and we'll come right to the topic. Okay, what the topic is? Topic is that we have to calculate e to the power t minus 1 plus e to the power t minus 2 plus e to the power t minus 3 plus e to the power 0, 1. Okay, where from this requirement arrived is, as we have talked, that we are talking about the bank problem. A bank is giving, someone is depositing money in the bank. When he is depositing money in the bank, then bank is giving interest, and interest is provided at the rate of C dollar or whatsoever, C amount per year. That is the interest rate that is provided, C amount per year. Okay, if we calculate the if person is depositing Y0 money, Y0 money in the account, Y0 money in the account, a person is doing fixed deposit in the bank. And when he is doing fixed deposit in the bank, he is depositing Y0, Y and subscript 0. Y and subscript 0 means that is the amount that is deposited at time equal to 0. Now question is arising that what is the money a person is expecting at the end of 1 year? Then that is Y0 plus Y0 into C. C is the interest rate, or Y0 in bracket 1 plus C. I can call 1 plus C as A. 1 plus C as A. Then person is getting Y0 into A amount at the end of 1 year. This is a compound interest. Compound interest means every year principal amount and interest amount, they will club together and it will become a new principal amount. That is called compound interest. Okay, after end of 1 year, it is Y0 into A. Now, end of 2 year, it will be Y0 into A. That is the principal amount at the end of 1 year. A is 1 plus C. Y0 into A. Now at the end of 2 year, it will be Y0 into A plus Y0 into A into C. Okay, Y0 into A I can take outside. It will become Y0 into A, and in bracket 1 plus C. That is A. Y0 A square. At the end of 3 year, it will be Y0 A to the power 3. More or less, it would become Y0 into A to the power T. Makes sense? Means whatever money I am depositing in the amount, in the fixed deposit, I have done fixed deposit in the bank. A bank is giving C% interest every year. C can be 8%, 5%. Typically, we have seen 5% to 8% in the bank. So it is, C is 8% means C equal to 8 by 100, 0.08. A is 1 plus C, 1 plus 0.08, 1.08, 1.08. That is what the A will be. Okay, if that is the scenario, then at the end of T year, Y in bracket small t bracket close, Yt equal to Y0 into A to the power T, where A is 1 plus C. Okay, now if I am visiting another bank, another bank is saying, now any money, if person is depositing Y0, after T year it is becoming Y0 into A to the power T, where T is in years. Now a person is visiting another bank and he is saying we are giving same C% as interest, same C. But compounding will happen every month, not every year. So at the end of 1 year, you will get more. If C is 8%, then 8 by 12. Every month means 8 by 12. 8% per year by 12 months. Every month you will get 8 by 12%, means 8 by 12 into 1 by 100. This much interest you will get every year, and principal amount and the interest will become a new principal amount every month only, not every year. So effectively at the end of 1 year you will get more. If that is the case, Then right now we have formula as y0 into a to the power t. A is 1 plus c. C will become c by n. If I talk about after 1 year, how much person is getting? Now we have to calculate monthly basis. 12 times it has to grow now. A will be different. If I just say that my money is compounding 12 times, I'm not saying 1 month, it is compounding 12 times. And one time interest is C by 12. C by 12 is a constant. How much it will be? It will be y0 that someone has deposited into a to the power t. T means how many time period is there? T is 12 months, 12 time period. A to the power 12. A will be 1 plus what is the C is the interest for that duration. Interest is C by 12. Now the calculation will be y0 into in bracket y now the kind of the slab what we are talking about the period, it is 12 now. Okay, first, second, third, fourth, 5, 6, someone can consider anything. Now if I see then the for each period what is the interest for each period, interest is C by 12. C is per year. So C by 12 is interest. Now we have Y0, A to the power T. T is 12 because 12 section we are computing. And C, A is 1 plus C and C is C by 12. So at the end of 1 year, person will get Y0 in bracket 1 plus C by 12 y0 1 plus c by 12 bracket close to the power 12. Makes sense? After 1 year. If someone is dividing into n part, 1 year into n part, not in 12 months, n part, n can be anything. N can be so big that it will be every day, 365 parts. Okay, then it will be y0 into 1 plus c, that is per year, c by 365 and bracket close to the power 365. Okay, altogether we can say it is y equal to y0 and in bracket 1 plus c by n bracket close and on top it n. That is the computation for 1 year. What about after t year? Then whatever someone has computed, he has to multiply it t times. That's it. So it will become y0 into 1 plus c by n bracket close. On top of it, it will be t into n into t. Make sense? Okay. Make n tends to infinity. Means person is not calculating, bank is not calculating every month, every day, every hour. Then n will be very high. Every minute, even high. Every second, then infinity. Okay, in that case, what the computation will be? A y0 in bracket 1 plus c by n, where n tends to infinity. C by n tends to infinity to the power n into t. If I have a computation like this, 1 plus x to the power 1 plus 1 plus 1 by n, mind it, 1 plus 1 by n to the power n, where n tends to infinity, this will be exactly as e to the power 1 or 1 plus x by n bracket close to the power n, where n tends to infinity, it will be equal to e to the power x. How it is? Y equal to 1 plus x by n to the power n. If I take logarithmic, log y equal to n log of 1 plus x by n. If n tends to infinity, then log 1 plus x by n will be x by n. Anyone can calculate. N into x by n gone x. Log of y is x, y is e to the power x. Okay, anyway, now if that is the case, then if I go with the compounding every moment, then whatever we had earlier y0 a to the power t, where t is broken into n different parts and n tends to infinity, then it will become y0 e to the power ct. Makes sense? Where a is 1 plus c. Now a is 1 plus c by n to the power n. Full term will become e to the power c to the power t, e to the power ct. y0 e to the power ct. This is called continuous compounding, not discrete compounding. Continuous compounding. If bank is giving continuous compounding, Every moment your principal amount and interest amount are summing together. Every moment, every second. Okay, in that manner, in that manner, it will be y0 e to the power ct. Means whatever money you have deposited, that will be multiplied by e to the power ct. T is in years. That we see. Okay, now concept is coming now. So we have modified our why we have modified our concept, that was money after t year is y0 a to the power t. If we break a to the power t, t is in year and every year compounding is happening in fractions, then it will be y0 into e to the power ct. Makes sense? Okay. If someone goes for differential equation, it will be dy by dt equal to cy. If I break it in differential equation, it will become dy by dt equal to c into y if someone breaks it. Generally, people go other way. Dy by dt equal to cy, then it will become y equal to y0 e to the power ct. But we went. These are not available in any of the book. Anyone can try. This is the way we started from the simplest case. Okay, now we know whatever money anyone is depositing the fixed deposit amount account after t years, t can be 1.1 year also, but t is in year, 1.5 year, 1.75 year, 3.5 year, that is the t. So y equal to y0 e to the power ct, where c is interest per year, 5%, 8%. 5% means 5 by 100, 0.05. If that is the scenario, if that is the scenario, then whatever amount some now consider the a well-wisher is depositing S amount every year. I have opened a fixed deposit account in the bank. I have opened a fixed deposit account in the bank, and I had deposited Y0 money at the beginning only. I had deposited Y0 money at the beginning only. And then any time if I want to see how much is available in my account, then that will be Y0 into e to the power ct, where c is the yearly interest rate and t is in year, where t can be in fraction. If I want to know at any moment what is the amount I can expect from this fixed deposit. Then later I came to know that one, I have a well-wisher and he is coming to bank, and then he knows my account number, fixed deposit account number, and S amount of money he is depositing every year. S amount of money he is depositing every year without my knowledge now. The question is arising, if that is the case, then how much money I can expect at any time t? How much money I can expect any time t? Question is clear, right? So if a well-wisher is depositing S amount, this is 1 year gap. At the end of 1 year, at the beginning of 1 year, I deposited a Y0 amount. At the end of 1 year, my Y0 has become Y0 into e to the power C into 1. That is the new Y0. Suddenly, one well-wisher is coming and he is depositing S amount. So at the end of 1 year, I have Y0 into e to the power C plus S. Makes sense? Okay, now at the end of 2 years, how much I will have? Whatever I will have, plus S amount is, because he is depositing S amount every year. Now how much I will have? Now I have two, if I am trying to calculate at the end of 2 years, how much money I will have? I have two streams now. One stream is Y0, that is compounding for 2 years. Y0 into e to the power C into 2. Then S amount that was deposited at the end of 1 year, that will be compounded for 1 year, plus S into e to the power C into 1, plus S someone is depositing. Means at the end of t year, we will have Y0 e to the power ct plus S e to the power C and bracket t minus 1, where S will go for t minus 1, plus S e to the power C e to the power C t minus 2, plus e to the power 0, because at the end someone is depositing S amount. So S amount is being deposited t times, but first only deposited after 1 year. So it will get chance to get compounded only for t minus 1 year. So at the end we have Y money in the account at any time t is y0 e to the power ct plus s and in bracket e to the power c and in bracket t minus 1 plus e to the power c and in bracket t minus 2 plus e to the power c in bracket t minus 3 plus e to the power c in bracket t minus t 0 e to the power 0 1. This is the amount someone can expect. Now can we compute e to the power ct, e to the power ct minus 1 plus e to the power ct minus 2, c and in bracket t minus 2, e to the power c t minus 3 plus e to the power 0. Can someone compute this computation? Or 1 plus e to the power 1 plus e to the power 2 plus e to the power, sorry, 1 plus e to the power c plus e to the power c into 2 plus e to the power c into 3 plus e to the power c in bracket t minus 2 plus e to the power c in bracket t minus 3. There are two. If anyone sees in the book how they have proved it, at least it went beyond my head. Okay, three methodologies. I have seen it. Okay, three methodology. I have personally seen it. Okay, there can be other methodologies also. What is other methodology also? People can go for okay, I don't know. Someone can try. People go for general differential equation solution. General differential equation solution. General differential equation solution is if you have something to solve, then take equal to a right side, make one independent variable. It is one independent variable can be t dt, and one side one independent variable can be y, and then compute y dy dt and then solve it whatsoever. Okay, whatever the available in the best books, at least I did not understand. That's why we are bringing this series, calculus series, because we will bring many series, not calculus series, artificial intelligence series, 3D graphics series, networking series, because whatever is available nowadays in market, many people are not understanding it, and they are coming to a complexity that they are not that intelligent. Personally, I have seen many times. People, when they read the book, people, they see the software, when they work into it, they feel that it is too complex and they cannot tackle it because probably they are not that intelligent, but probably it is other way. People who are not that intelligent, they have written in a so complex manner that a real intelligent person is not able to understand, and he is coming to gloomy. Okay, so we are here to make things simple. Things are not that complex the way it looks. Okay, now there are two ways I can find out e to the power c in bracket t minus 1 plus e to the power c in bracket t minus 2 plus e to the power c t minus t. There are two ways. One way we have said that do one thing. Instead of minus 1, minus 2, minus 3, make it minus x. Divide this problem into n different parts. If I this big is the problem, then divide the problem into n different parts. If you divide problem into n different parts, first is e to the power c and in bracket t minus x. Next is e to the power c in bracket t minus x. All are e to the power ct. This is called repeated summation. We are trying to sum things repeatedly. If there is a repeated summation, then we can bring into multiplication. If I have e to the power c in bracket t minus x, this is repeated for x time, I can write as e to the power c in bracket t minus x into x. If I have repeated addition e to the power c and bracket t minus x plus e to the power c in bracket t minus x, actually that is happening t times, small t time, that is year. If I say it is happening for x time, then e to the power c and in bracket t minus x and down into x. Okay, I believe it is all right. Okay, now if I have, now there are two things. One is function over x and one is x multiplication. Function over x is e to the power c in bracket t minus x, and multiplication with x, that is in there. So if I have two things, function over x multiplied by x, then I have one independent variable x multiplied by dependent variable of function over x. If this is the case, It is a fit case to turn into integral calculus. Fx into x, fx into dx. Okay, whatever the x is, whatever the elongation of x is, whatever the period of x is, whatever the stretch of x is, that stretch I can place in limit now. Makes sense? What do you want? I want 5 into x, where x can be anything. 5 into x is same as 5 into 1 when x is 1. 5 into 10 when x is 10. Okay, so this is a variable. So e to the power c t minus x into x, x time. This is same as dx. What is dx? Okay, consider I was trying to sum it, e to the power c t minus x, I was trying to sum it 10 times. Then it will become e to the power c t minus x into 10. Instead of that 10, I am writing it as x into x. X as dx. If that is the case, then dx will become 0 to 10. Limit will become 0 to 10. Understandable, right? 5 into x, where x is 10, that is 50. Or 5 into dx, then make a limit. If 5 into x and x is 10, then no problem, 50. But 5 into dx, I am transforming this multiplication into integral calculus. Integration is nothing but multiplication only. So where is in multiplication, it is required that first part should be a constant. If it is not constant, it should not be dependent upon second part. If first part is dependent upon second part and first part is not a constant, it's a variable, then the settlement of this multiplication will happen through graphical way, where you have x-axis and another is function over x-axis, that is the first operand in the multiplication. Okay, then it will settle down through area or through integral calculus. That's it. So if I have e to the power c and t minus x into x, what is x? X is 5, 6, 10, whatsoever. If I replace x with dx, then whatever I was saying 5, then 5 will come in limit now, 0 to 5. Makes sense? So now I'll say it is e to the power c t minus x dx, where x is 0 to t, because it is getting added for t times. If I say 5 is added 7 times, then 5 into 7, 5 into x, where x is 7, or 5 into dx, where limit is 0 to 7, all are same. Similarly, if I'm trying to add e to the power c t minus x t times, then I can write as e to the power c t minus x dx, and x is 0 to t times. Next, same. Okay, now someone very good in integral calculus, he can integrate e to the power c t minus x. This is not available in any of the book. Anyone can try. Any book. E to the power c t minus x dx. If I integrate it, it becomes e to the power c t minus x divided by 1 by c. C, it will be minus cx divided by 1 by minus c. E to the power ct minus cx, integration will be 1 by minus c. It will be minus 1 by c e to the power c t minus x. That will be the integration. Limit is 0 to t. If I place t, it will become 1. E to the power 0 is 1. If I place 0 out there, then it will become e to the power ct. 1 minus e to the power ct multiplied by minus 1 by c. 1 by c e to the power ct minus 1. This is what is placed in any of the book. I mean, this result is placed, not this way. This is $1 trillion proof. Repeated summation can become integral calculus, multiplication, and then it will turn up into integral calculus. Okay, I believe up to here it is all right. Then what will be the net yt, what we were calculating? Y, that is the principal amount at any time. Y is principal amount at any time. So that amount at any time is y equal to y0 e to the power ct plus s into bracket e to the power ct minus 1 e to the power ct minus 2. That will become 1 by c, and in bracket e to the power ct minus 1. Total, if I calculate total, then it will become yt, y at any time t, amount in the fixed deposit at any time t, y at any time t, equal to y0 e to the power ct plus s by s by c, and in bracket e to the power ct minus 1. Make sense? This is one way to prove it. What is other way to prove it? Okay, other way to prove it is, I try to cover it if it is possible. Consider that I am trying to calculate. I have a function called e to the power x. Makes sense? When x is 0, this is x-axis. This is x-axis, and this is x is 0, and this is x is 1, x is 2, x is 3. I have a graph like this. When x is 0, e to the power x is 1, that is the height. Now it is growing like this. When x is 1, then it is the power 1. E to the power 1 means it is 2.78 or something like that. So it will grow like this. After that, it will grow exponentially. Consider, I have chopped it 10 times. I have chopped it 10 times. If I chop it 10 times, now I have at x, now this is x is 1 by 10, 2 by 10, 3 by 10, 4 by 10, 5 by 10. Like that, I have 1 is 10 by 10. I have chopped it 10 times. And now I have vertical at each chop. I have vertical at each chop. Now here, when it is 1 by 10, it is e to the power 1 by 10, e to the power 2 by 10, e to the power 3 by 10, e to the power 10 by 10. Means whatever I had a graph of e to the power x from 0 to 10, I chopped it 10 times, starting with 1 by 10. I chopped it 10 times. Now, if I chop this, what I chopped means, if this is the graph, I chopped it 10 times. Now, I have 10 vertical bar. One is x equal to 1 by 10, x equal to 2 by 10, and then it will go with x equal to 10 by 10. Tell me, what is summation of all? Summation I equal to 1 to 10. Summation I equal to 1 to 10. Summation means sigma sign. Summation I equal to 1 to 10 e to the power I. I'm sorry. Summation I equal to 1 by 10. Summation I equal to 1 to 10 e to the power I by 10. Yeah, this is what I want. Summation I equal to 1 to 10, sigma sign I equal to 1 to 10. And then in summation e to the power I by 10. So it is e to the power 1 by 10 plus e to the power 2 by 10 plus e to the power 3 by 10. These are the 10 heights. Now tell me how I can add it. Someone will say, I know, I have calculator. And very quickly in the calculator, I am going to add it. Okay, boss, you can add it. No one is stopping you. Okay, can you tell me if I chop it 100 times, then no, sorry, not possible. 100 times I cannot calculate through calculator. Each time you have to find e to the power 1 by 10 or e to the power 1 by 100 plus e to the power 2 by 100, like this. Can you calculate if I divide it into 10,000 times? Chop 0 to 1 into 10,000 times, and all the verticals you have to add now. Is it possible? Anyone would say it is not possible. It is very difficult. Okay, then can we use calculus? Calculus means if I have innumerous number of addition, then can we use calculus? Okay, to use one calculus way we have talked now. That calculus way is that if I prove this equation in a repeated addition, then I can solve it. What is other concept? If I am saying I have summation I equal to 1 to 10,000, I equal to 1 to 10,000, e to the power 10,000, e to the power I by 10,000, summation I equal to 1 to 10,000, and in summation e to the power I by 10,000. Now you sum it. Okay, if someone is trying to sum it, then for him it is very difficult. But he knows the formula though. What is the formula? Formula is e to the power x, where x is 1 by 10,000. Then x is 1 by 2 by 10,000, 3 by 10,000, like that. Okay, for simplicity, if I make up to 10 only, then 1 is e to the power 1 by 10. Next is e to the power 2 by 10. Means it is in formula of e to the power x only, where x is growing as 1 by 10, 2 by 10, 3 by 10, not as 1, 2, 3, 4. Okay, then can someone calculate it? Okay, if I say that I have a function called gx, what is your fx? My fx is e to the power x. This is my fx. And I sampled it 10 times between 0 to 1, and then I'm trying to add all the samples. But formula is e to the power x. Consider that is fx. Consider that is fx. If that is fx, then I have another formula called gx. Okay, and gx dx, if this is fx, then I have another formula called gx. I have invented it. And if I calculate integration of gx from x0 to 1, then it will give the area underneath it. And that area is exactly equal to summation I equal to 1 to 10 e to the power I by 10. Exact. What is that gx? Can you tell me that secret? Okay, that secret I don't know, but I think in that fashion. Then why you are talking like this? You have to tell me what is gx. Okay, can we try with the fx? Well, let's try. Who is stopping us? If we try with the fx, then fx dx, considering fx e to the power x is the formula, try to calculate the area underneath it between 0 to 1. E to the power x dx, integration will be e to the power x1 from x0 to 1. Okay, e to the power 1, it will be e to the power 1 minus e to the power 0. That will be 2.78 minus e to the power 0 is 1. 1.78. It will come as 1.78. Now, if someone is adding all 10 parts, then the end is e to the power 10 by 10. That is e to the power 1. That is e to the power 1. Makes sense? E to the power 1 is 2.78. Here the solution is 1.78. Now if I add all, it will go beyond 10, I think so, or beyond 5. So summation is much more than what we will get through normal integration. Okay, then how I can proceed here? That is the question. Okay, someone can try. Someone can try how to compute if I divide e to the power x 10 times between 0 and 1, all the verticals if I try to add, how I can achieve through integral calculus. Okay, someone can try. Okay, we will see what is the concept that we have brought in. Fx equal to integration gx dx. This is what we are saying. Fx, that is the sampling we are saying. Fx, that is e to the power x, equal to integration of gx dx from lower limit to higher limit. I have to find gx. If I find gx, then we can do so. What is gx? Gx, if fx equal to gx dx, then gx is fx by dx, dfx by dx. That will same as e to the power x only. Okay. Now in that fashion, if I take x-axis, then I have 10 verticals that I have to add. Okay. If I take one, if I have another function gx, and if I take any point x here, then next vertical is at x plus 1 by 10, because gap is 1 by 10. If I take one vertical at x, next vertical is at 1 by 10. Okay, means the vertical that is at x equal to x is e to the power x. But if I go with the continuous function integration, that is gx, then gx dx between x and x plus 1 by 10, this area, this area will be equivalent to whatever I had sampling at x. Makes sense? I have 10 samplings. One sampling is 1 by 10, 2 by 10, 3 by 10, 4 by 10, 5 by 10, like that. Let's take any sampling at x. The next sampling is at x plus 1 by 10. At x, the discrete function height is e to the power x, where I have another function called gx. For gx, if I say gx dx, that will give the area of gx dx between x and x plus 1 by 10. If I calculate that area should be exactly at what we have fx, that is e to the power x. If that is the case, then this sub area plus this sub area plus this sub area, that is dx dx, if I add all, it will become dx dx area, that will be exactly same as summation I equal to 1 to 10 fx. or e to the power I by 10. Same thing. Makes sense? Now I have to find now through approximation, through the repeated approximation, I have to settle down for one gx that will be exactly same. What is that? Fx equal to integration x to x plus 1 by 10 gx dx. Fx is e to the power x equal to integration x to x plus 1 by 10. That is the sub area between x and x plus 1 by 10 dx dx. If I settle it down slowly, phase by phase, and come to a concrete GX, then I can crack it. This is $1 trillion explanation. If someone really proceed in this area, then he can do very big thing because general addition is too many in the market. Okay, then solving it will be a big deal. We will proceed in this. Please do not mind supporting us. +91 is India country code 9483160610 is the telephone number. +91 is India country code 9483160610 is the telephone.